Welcome back. Today we're starting a new topic, probability. So in everyday life, you probably have all used these terms here to communicate to somebody how likely something is to happen. If your friend asks you, hey, are you going to the gym today? You might respond with, probably, or maybe. So the problem with these terms is that they're not very precise. If you ask me if I'm going to go to the gym and I say, maybe, I'm probably not going to go. But if you say maybe, you might mean 50% chance you'll go, 50% chance you won't go. So these terms aren't very precise. To make them more precise, we're going to attach numbers to probabilities. What is a probability? A probability is just a number that measures how likely something is to happen. And it's a number between 0 and 1. So these are in decimal form. You might be more used to probabilities in terms of percents. So 0 as a percent would be 0%. 1 converted to a percent would be 100%. So 0% means that it's never going to happen. So when you say impossible, you probably mean 0%. It's never going to happen. 100% means it's for sure going to happen. And then you can have any percent in between. So when I say maybe, I probably mean like 10% chance I'll go to the gym. But when you say maybe, you might mean 50% chance. How do we actually compute probabilities? For us, probabilities are going to be fractions. On the bottom, you're going to count all of the number, you're going to count all of the possible outcomes. In a particular situation. And on top, you're going to count the number of desired outcomes. And this is going to make more sense once we talk about some examples. Okay, what I want you to pay attention to today are the words and the word or. Okay, so I'll give you more details once we encounter these words in a problem. Example 1. Consider a following table which relates a student's 2-year college with their transfer admission status at UC Davis. Let's first talk about how you read this table. This 6. What does this 6 mean? This 6 means that there are 6 students who are from Sierra College, and at the same time they were accepted to UC Davis. What about this 2? These 2 students are from Sierra C, and at the same time they were waitlisted at UC Davis. Part A. If one student is selected, find the probability that the student was denied. Probability is going to be a fraction. We're talking about picking students here, so for the bottom, how many possible students could I have picked? That's just asking how many students are there, right? How many students are there total? So let's add up all these numbers and get a total. 11 plus 3 plus 2 plus 7 plus 6 plus 3 plus 6 plus 2 plus 0. 40. Okay, so there's 40 students total, so I could have picked 40 students. That goes on the bottom. For the top, we're talking about probability that the student was denied. So how many students were denied? That's these 3, these 6, and these 2. All of those students were denied. So 3 plus 6 plus 2. 11. And that's a probability. So probability of getting a student who was denied is 11 out of 40. That's a fraction. We can also convert this to a decimal. So 11. To convert it to a decimal, you're going to divide 11 divided by 40. and we get 0.275. And then we can also convert this to a percent, which we're probably more used to. So 0.275 as a percent would be move the decimal 2 to the right, and you get 27.5%. So there's a 27.5% chance of selecting a student who was denied. Now for your lab, just enter the fraction, right? Don't worry about the decimal or the percent. Just enter the fraction. Part B. If one student is selected, find the probability that the student was not from Delta College. Okay, again, the bottom is going to be everybody. So everybody would be 40. Up top, how many students are not from Delta College? Okay, here's the Delta College students. So not Delta College would be the top row together with the bottom row. Okay, so top row together with the bottom row. 11 plus 3 plus 2 plus the bottom row 6 plus 2 plus 0. 24. Okay, I'm not even going to bother with the decimal or the percent, just a fraction. Part C. If one student is selected, find the probability that the student was from CRC and was denied. So keyword here is the word and. The bottom is still the same as before, everybody, which is 40. Now the top. How many students are from CRC and was denied? When I say the word and, I mean at the same time. Okay, so how many students are from CRC and at the same time were denied? That would be just these 3 students. So these 3 students are from CRC and at the same time they were denied. So just 3. As a tip for ands, it should be just a single number on your table. And to tie this back to the set theory unit that we just finished, ands correspond to intersections. And what I'm doing here is I'm taking the set of CRC students, the set of students who were denied, and then combining them, not combining them, looking at the intersection, okay, which is the students who are in both sets at the same time. So the students who are both CRC students and at the same time denied. Okay, intersection. Part D. If one student is selected, find the probability that the student was from Delta College or was accepted. Keyword here is the word or. The bottom still the same, everybody, which is the 40. The top. If and corresponds to intersection, or corresponds to union. And union, remember, is we're taking the 2 sets and combining them to get a bigger set. Okay, so here I want delta union accepted. And so what I want is the delta numbers, which are 7, 6, 3, union with the accepted numbers, which is 11, 7, 6. And I don't want to count the 7 twice. I don't want to count this twice. So the way you do this is, usually I just start with the first set, which is Delta College. So 7, 6, 3. So 7 plus 6 plus 3. And then add on the accepted numbers. But remember not to count the number that you counted already with the delta numbers. So for the accepted, just the 11 and the 6. Because the 7 I already got when I added the delta numbers. So just 11 and 6. Okay, bottom still 40. Up top, 7 plus 6 plus 3. Plus 11 plus 6. And that's 33. Example 2. If a 20-sided die is rolled, what's the probability of getting an even number? Here's a 20-sided die. Okay, the bottom is going to be the total number of things that could happen when I roll this die. So when I roll this die, it's a 20-sided die, so you could get a 1, could get a 2, 3, 4, 5. when you roll this 20-sided die, you could get a 1, a 2, a 3, a 4, all the way up to 20. So 20 things could happen. That's the bottom. For the top, how many numbers are even? Okay, so the even numbers are going to be, I'm going to circle the even numbers. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, top's going to be 10. Part B. If a 20-sided die is rolled, what's the probability of getting a multiple of 3? Bottom's still going to be total, number of things that can happen, which is 20. How many multiples of 3 are there? Okay, multiples of 3, count by threes. I'm going to put a box around the multiples of 3. So 3, 6, 9, plus 3, 12, 15, 18. Okay, I'm just going to count. I'm just counting by threes there. How many multiples of 3 are there? So how many boxes are there? So that's 1, 2, 3, 4, 5, 6. 6. Part C. If a 20-sided die is rolled, what's the probability of getting an even number or a multiple of 3? Keyword here is or. Bottom's going to be the total, which is 20. Okay, or. Or means I want to take the even numbers, multiples of 3, combine them and get a bigger set. So what that means is just take all my circle numbers, all my box numbers, and just combine them. So just count everything that is marked in red here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm counting everything that I marked in red. I forgot what I counted. What was it again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13. Part D. If a 20-sided die is rolled, what's the probability of getting an even number and a multiple of 3? Okay, keyword here is and. Bottom's going to be everything, which is 20. Okay, and means at the same time. Okay, so I want the ones that are even and at the same time multiples of 3. In this picture, I want the one that is circled and at the same time boxed. Okay, so how many are circled and at the same time boxed? That's 1, 2, 3. Okay, so there's 3 numbers that are both circled and boxed at the same time. 3. Part E. If a 20-sided die is rolled, what's the probability of not getting a multiple of 3? Okay, bottom is still all the possible things that can happen, which is 20. For the top, not multiple of 3. Multiples of 3 are the boxes. How many are not boxes? So not boxed would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. For example 3, we'll be working with a deck of cards. So let's first talk about what a standard deck of cards looks like. Here's a standard deck of cards. I'll include a link to this picture on every question that you'll need it on. Notice that there are black cards and there are red cards. More specifically, the entire first row here are called black clubs, so that refers to the color and also the symbol that's on the card. So that's called a club symbol. We have black spades, that's the spade symbol. Red hearts, you see a heart. Red diamonds, you see a diamond. Now, for each row, notice that it goes from A, 2, 3, all the way up to 10. So think of the A as 1. So 1 through 10, Jack, Queen, King. Jack, Queen, King are called face cards because you can see a face on them. And I think the last thing I need to tell you is how many cards are there total. Okay, 1 through 10, Jack, Queen, King, that's 13 on each row. And there are 1, 2, 3, 4 rows. So 13 times 4, that's 52. 52 cards total. Back to example 3, part A. If a card is selected from a standard deck of cards, what is the probability of getting a king and a red card? Keyword I see here is the word and. Okay, so for the bottom, if I pick a card, how many possible things can I get? In other words, how many total cards are there? We said it was 52. For the top, I want king and red. So and, remember, means at the same time. So I want the cards that are king and at the same time red. In other words, I'm looking for the red kings, which are these two. Part B. If a card is selected from a standard deck of cards, what is the probability of getting a diamond or a black card? Keyword I see here is the word or. Bottom is going to be everything, so that's 52 again. Up top, I want diamond or black. So, or means I want to take all the diamonds and combine them with all the black cards and then count those. So all the diamonds, which is the bottom row, together with all the black cards, which are the top two rows. Okay, combine them together. So that's first row, second row, last row. How many cards are there? There's 13 cards in each row. So first row, second row, last row, that's 3 rows. Pretty sure that's 39. So 13 times 3, 39. Part C. If a card is selected from a standard deck of cards, what's the probability of getting a face card or a red card? Keywords or. The bottom is going to be the total number of cards, 52 again. Up top, I want face or red. Okay? Or means I want all the face, combine them together with all the reds. So all the faces are over here, so the last 3 columns, together with all the reds, which is the last 2 rows. Okay, so last 2 rows together with all the face cards. And I don't want to count any card twice, right? So that's going to be the bottom 2 rows, which is 26. And then add on the face cards that I haven't added yet. So 26 for the bottom 2 rows, and then 27, 28, 29, 30, 31, 32. 32. Part D. If a card is selected from a standard deck of cards, what's the probability of getting a face card and a black card? So keyword there is the word and. Okay, bottom same as before, 52. And means at the same time, so I want the face cards that are at the same time black. Okay, so I'm looking for face cards that are at the same time black. So black face cards. Black face cards would be Jack, Queen, King, clubs, Jack, Queen, King, spades, 6. So those are the face cards that are at the same time black. Part E. If a card is selected from a standard deck of cards, what's the probability of not getting a face card? Bottom is going to be 52 as usual. Okay, not face cards. So how many not face cards? Not face cards would be 1 through 10, 1 through 10, 1 through 10, 1 through 10. So 1 through 10 on all the rows. So 1 through 10 times 4, 40. Example 4. Here we have another table question, just like in example 1. The only difference here is that I'm not giving you the numbers inside the table. You have to read the information I give you and then fill in the table first. So let's just go through line by line. Researchers asked 80 people to name their favorite mode of transportation. That's telling me that the total is 80. Next sentence. Out of the 80 people who were surveyed, 14 named car, 30 named train, and 36 named plane as their favorite mode of transportation. So 14 people named car. It doesn't specify the city, right? So I can't fill in any of the boxes yet, but I do know that the total for car needs to be 14. So if I add up the first column, it should equal 14. So let me put 14 on the outside here. 30 people named train, so I know that the total for the trains should be 30. So I'll put 30 on the outside here. And then 36 people named plane, the total for plane should be 36. Next sentence, of the 24 people from San Francisco, there were 5 who preferred travel by car and 9 who preferred travel by train. Okay, so that's 3 numbers there. Of the 24 people from San Francisco, that's telling me that there's 24 people from San Francisco. The total for San Francisco should be 24. Okay, I'll put 24 on the outside here. There were 5 who preferred travel by car. So we're still in the same sentence, right? So of the 24 people from San Francisco, there are 5 who prefer travel by car. So these 5 people are San Francisco car. Okay, San Francisco car would be this box right here. So this box is San Francisco car. So that's 5. And 9 prefer travel by train. So we're still in the same sentence talking about San Francisco people. So these 9 people are San Francisco train. So San Francisco train, this box here, San Francisco train, that's 9. Next sentence. 3 people from Los Angeles prefer travel by car. And 12 people from Sacramento prefer travel by plane. Okay, so 3 people from LA prefer travel by car. So 3 are LA car. So LA car would be LA, that box there. That's going to be 3. 12 people from Sacramento prefer travel by plane. So 12, Sacramento plane. Sacramento plane, Sacramento plane, 12. There are 23 people from Los Angeles. Okay, that tells me that the total for Los Angeles should be 23. And that's all the clues. So from here, fill in the boxes, kind of like a, was it Sudoku puzzle? So where should I start? I can start right here because I know that the total should be 24. Right now I have 5 and 9. Okay, so right now I have 5 and 9, which is 14. What's the missing number so that the total adds up to 24? So what you can do is just add up the numbers you have right now. So 5 plus 9 is 14. And just do 24 minus 14. That's 10. Okay, you can check. 5 plus 9 plus 10 is 24. What can I do next? I can do this box, okay, because I know that the column should add up to 36. Right now I have 12 plus 10, which is 22. To find a missing number, I can just do 36 minus 22. So 36 minus 22. 14. You can double check. 12 plus 10 plus 14 is 36. Where next? I can probably get this box because I know that the total of this row should be 23. Okay, so 3 plus blank plus 14 equals 23. Right now I have 3 and 14, that's 17. To get the missing number, I can just do 23 minus 17. So 23 minus 17, 6. Okay, so 3 plus 6 plus 14 is 23, so that's good. I can go this box because I know that this column should add up to 30. Right now I have 9 and 6, which is 15, which means the missing number would have to be what? 15. Okay, so 15 plus 9 plus 6 should be 30. Let's double check that. 15 plus 9 plus 6. Okay, it is 30. And then I have one missing number here. I also know that this column should add up to 14. Right now it's 5 and 3, which is 8. So missing number would have to be what? 6. Okay, 6 plus 5 plus 3 is 14. Yeah. All right, I think we're good. So now that we have the numbers in the table, now this is just basically example 1 again. Part A, if one person is selected, find a probability that the person is from Sacramento. Bottom is going to be total of everybody, which is 80. How many people from Sacramento? Sacramento would be the entire first row, so 6 plus 15 plus 12. 33. Part B, if one person is selected, find a probability that the person is from San Francisco or prefers travel by train. So keyword here is or. Bottom is going to be everybody, which is 80. Okay, or means I'm going to take the two groups and combine them together to get a bigger group. So I'm going to take all my San Francisco numbers, which are 5, 9, 10, and then also combine the train numbers, which is 15. I don't want to count the 9 twice because I already got it with the San Francisco numbers, so just the 15 and the 6. All right, so I'm going to do 5, 9, 10, which are the San Francisco numbers, and then combine 15 and 6. And I don't want to count that 9 twice. Okay, so on the bottom is 80. On top, 5 plus 9 plus 10. Plus 15 plus 6. That's 45. Part C, if one person is selected, find a probability that the person's preferred mode of transportation is not train. Bottom is going to be 80, the total. The top, not train. So not train would be first column, last column. So 6, 5, 3, 12, 10, 14, 50. And finally, part D, if one person is selected, find a probability that the person is from Los Angeles and prefers travel by train. Keyword is and. The bottom is going to be the total, which is 80. And once again means at the same time. So LA and at the same time plane. So and for table questions, remember, as a tip, should be a single number. So LA plane. LA at the same time plane will be these 14. So these 14 people from LA, at the same time, they like plane. 14. And that's it for today. Have a great day. See you next time.